So, next thing I want to talk about here, we've talked about how Alexander Friedman's work showed that using Einstein's equations, the universe is expanding or contracting. So, expanding had a beginning, it's keep going forever. Rather, it's expanding. Okay. Edwin Hubble's work was very popularly and well known work showing that, in fact, the farther away things are, the faster they're going. That's exactly what you expect from an expanding universe. George Lemaitre had likewise proposed something very similar, expanding universe from his observations. He made the mistake, though, of proposing primordial atom, running everything backwards. An idea that was later discounted. It was discounted in part, and the interesting thing is that he proposed, origin of the universe here, and primordial atom, and we talked about how a fellow named Fred Hoyle came up with the term Big Bang as a rather derogatory term to describe Lemaitre's primordial atom. The Hubble-Lemaitre law, very good at explaining how everything works. Expansion of the universe. And in fact, space itself is expanding. It's not that things are blowing away into space, but space itself is expanding. Okay. Well, Fred Hoyle had talked about that because he was actually, one of these people that insisted that the universe did not have a beginning. It is always there. A beginning of the universe means that you have to describe why it even had a beginning, what happened to make it start, and a lot of theorists weren't willing to go there. And so it's a lot simpler to say it was always there, because if the universe is expanding like this, then you take the slope of the Hubble-Lemaitre law, and 1 over that slope gives you time, and we call that the Hubble time. This is a ballpark estimate of the age of the universe. And so Fred Hoyle was completely unwilling to accept that the universe had a beginning. And so he comes up with an entirely different alternative. Hoyle, Bondi, and Gold resurrected an ancient idea of an eternal universe that's always been there. Just hadn't had humans in it for all this time, but that we came along at some point in here into the universe that already been there. And his idea the universe is always expanding, as it expands, then new things start popping into the middle here, new matter, new gas coming together to make new galaxies up in the middle. So once it expands far enough, new stuff just goes poof into the middle, and so you end up with a constant level of the universe. It's always the same. So that's what you would always see. That's not what we see when we look out into space. But his idea was the universe would be more or less constant density. As it expands, as things get farther apart, more things appear in the empty space to maintain a constant density of the universe. More galaxies appear, more stars appear. Now, the problem with that is that this doesn't conserve mass or energy, because now all of a sudden it's just like poof, new stuff is appearing in the empty void. And that doesn't seem to make sense. How does that work? I mean, how can you have this new stuff just suddenly appearing in there? So that doesn't make sense. The other thing is that if new stuff is appearing, if you're looking across the universe, then you would see some things that are near to you, some things that are younger, some things that are younger, the new things that appeared, but beyond them are some older things as old as our Milky Way. And we don't see that. We see no evidence that we look further out there that at any point we see anything older. In fact, the farther away we look, the younger things that we see. But we never get to the point that we see anything older. It's just that younger, younger, younger until we get to the edge of what we can see. That's more consistent with the universe having a beginning. And the farther away you look, the farther back in time that you're looking. And so that means that the steady state model, which is what he calls this, Hoyle, Bondi, and Gold, they come with this idea called steady state model to explain a universe that never changes. Because Otherwise, as the universe expands, the density of galaxies would drop and the character of the universe would change. Well, that is, in fact, exactly what we see. When we look farther and farther away, we see a universe that's quite a bit different than the universe around near us today. And so the types of galaxies that are there, the nature of everything is different the farther away we look. Again, this is consistent with a universe that had a beginning, not one that was always there. Um, again, Hoyle's idea involves, for example, a universe that's infinitely big and just expanding and expanding and expanding, and it's infinitely big and infinitely old and just keeps expanding, and new things just popping in now and then. And that is completely inconsistent with the observations that we have. But that was his idea as a way of maybe avoiding the idea of the universe having a beginning. For a while, a few scientists, not very many, it was actually always a minority, kind of accepted the steady state model. And when I was a student in school, they actually taught both the Big Bang and the steady state. The Big Bang they actually got wrong how they taught it, because they taught it as primordial atom, and then they taught steady state as an alternative. But that the idea was pretty much discounted as a realistic alternative back middle of the 20th century, and was thoroughly discounted as an alternative towards the 1970s and 80s. And so anyway, but this I did think that you ought to have at least some mention of it. The book kind of like very briefly mentions that there was a steady state alternative, but this is kind of what it is, and it's like today it is not at all accepted by any cosmologist, but it was for a temporary time something that they thought about.